Hello student, welcome to Power Electronics Lab. In this section, we are going to learn single phase and three phase uncontrolled diode rectifier with capacitor filter. MATLAB 19A simulation block and path. So using this path, select all the blocks. Simulation implementation on single phase diode rectifier with R and C loads. Input voltage 50 peak equal to 35.35 RMS and frequency is 50 Hz. R is 100 ohm, C is 5000 microfarad. Simulation implementation on three phase diode rectifier with RC load. Input voltage 50 peak equal to 61.2 RMS and frequency is 50. R is equal to 100 ohm, C is equal to 5000 microfarad. Now we will do the simulation. Now double click on MATLAB icon on desktop. Now double click Simlink. In Simlink, select belong model, double click belong model. Now your model open with untitled name. Now this one you have to save with some file name. For this, go to file, save as. I am saving it exp4. Save. Now your model is saved with exp4. Here you are design your simulation model. For this you need a blocks. For this, go to library browser. In Power Electronics path is first select as a Simscape. Under Simscape electrical. Under this specialized power system, fundamental block, power GUI, power electronics, measurement, elements, electrical sources. First select as a power GUI, add to model, double click power electronics, select diode, add to model. Go back, double click measurements, select current measurement, add to model, select voltage measurement, add to model. Go back, select double click elements. In that, select series RLC branch, add to model. Go back, electrical sources, select as a AC voltage source, add to model. Now you need a mean and RMS block, control measurements. In that measurement, select mean, add to model. Select RMS, add to model. Now you need a scope. This will be available, scope and display in it will be available in the under SimSkim, Simulink, Sync. Select scope, add to model. Select display, add to model. Now we got all the blocks. Now we'll separate all the blocks. Now double click AC voltage source. Peak amplitude is nothing but we have to give as a RMS 35.35, frequency 50. Apply and OK. Now here we require as a 4 diodes. Now rotate this diode. Now this one label it as a D1. Now copy this one to as a D3. D4. D2. Now D1 anode to D2 cathode, D3 anode to D2 cathode, D1, D3 cathodes joining, D4 and D2 anodes join. Now from AC voltage source, one terminal is connected to current measurement, one terminal plus terminal, negative terminal to D1, D4 anode and cathode joining point. AC voltage source, second terminal connect to D3, D2 anode and cathode joining point. Now select series RLC branch, double click this series RLC branch, branch types, select as a OR first, OR is 100 ohm, apply and OK. Now copy this one, double click, branch type select as a C, that is 5000 microfarads. Rotate this one, Control plus R. This one also rotate, Control plus R. Now capacitor terminal to both the D1, D3 cathodes are joint point, capacitor negative to D4, D2 anode points. Now load across this. Now here also you want to measure current. Select one more current measurement. Voltage, this volt is measuring across the load voltage. Now this voltmeter measure the input voltage. This mean and this RMS for currents. This mean and this RMS is output voltages. Now you can double click the scope, add number of input. For this, go to configuration properties, number of input port to 4, layout 4, apply and OK. Input voltage, input current, output voltage, output current. Now mean to this terminal, RMS to current measurement, output terminal. From this mean also connected to output voltage terminal, RMS to output voltage terminal. Now this mean to block, display block, RMS to display block, mean to display block, RMS to display block. Now double click mean block, fundamental frequency 50, apply and OK. Double click RMS, fundamental frequency 50, double click mean block, fundamental frequency 50, double click RMS block, fundamental frequency 50. Now can take a format, go to here, format, display the block, show block name, scope, here mean, current, RMS current, mean voltage, RMS voltage. Now you design the single phase uncontrolled rectifier with RC. Save this file by pressing save button. Now here simulation time, instead of 10 give as a 0.5 second. Now run simulation by pressing run button. Now mean current, RMS current, mean voltage, RMS voltage. Now you can see the input, output, voltage and currents. Double click the scope. Now this has an input, voltage, input voltage, apply and OK. Second one is input current, third is output voltage, fourth is output current. Output current. Apply and OK. Now we can easily identify which waveform is this. So first is the input voltage, second is input current, third is output voltage, fourth is the output current. Now this one you can take a screenshot, save in the result, some folder name, folder, now we'll do as a three-phase circuit. Now we are done only simulation on single phase RC circuit. Now we'll do as a three-phase circuits. Take new file, save with file name, save as exp4-1. Don't, it's not taking, so you will give as a 4-1 like this. Save. Now for this, again you to go to library browser, in that Simscape electrical specialized power system fundamental block, select power GI, add to model, power electronics, select diode, add to model, go back, measurements, three-phase VI measurement, voltage measurement, current measurement, go back, elements, select series RLC branch, add to model, electrical sources, three-phase source, add to model. Now you need a scope and display for this. Under Simulink, select sync, select as a scope, add to model, select display, add to model. Now we'll design the circuit. First double click three-phase source. Here phase to phase voltage 61.2 RMS, frequency 50, apply and OK. And configuration, store with neutral, internal select, and source resistance 0, source inductance 0, base voltage also give 0. Apply and OK. Now select three-phase VI measurements, voltage measurement. In that, select phase to phase, apply and OK. Now here in the 3-phase circuit we required as a 6 diodes. Now first rotate this diode, Control plus R, as a D1. Now first diode is D1, copy to next diode D3, copy next diode D5, copy one more diode D4, D6 diode, D2. Now double click series RLC branch. First select as a R as a 100 ohm. Now this one we have to rotate by Control plus R. Now copy this. Double click this one. Go to branch type. Here select as a C. That is 5000 microfarad. Apply and OK. Now A to A, B to B, C to C. This is as a 3-phase supply giving to VI measurement. Now D1 anode to D4 cathode, D3 anode to D6 cathode, D5 anode to D2 cathode. Now D1 cathode to D3 cathode, D5 cathode to D3 cathode. D1 anode to D6 anode, D2 anode to D6 anode. Now capacitor terminal to D1, D3, D5 cathode, all the joining points. Capacitor negative terminal to D4, D6, D2 anode joining points. Now measure current, output current, positive to here, negative to resistive load other end to capacitor terminal. Now can connect this voltmeter across a load. It is measuring load voltage. Now A terminal to D1, D4 anode cathode joining point, B to D3, D6 anode cathode joining point, C to D5, D2 anode and cathode. Now you want to increase the number of input to scope. Double click the scope. Go to configuration properties. Number of input port to 4. Layout 4. Apply and OK. Now first we'll connect VABC first terminal, IABC to second terminal, load voltage to third one, output current to fourth one. Now we'll take as a mean and RMS blocks. Control and measurements in that measurement blocks. Select mean, add to model, RMS, add to model. Now mean to output current terminal, RMS to output current terminal, mean to display, RMS to display. From this mean to across the load voltage output terminal, RMS to output voltage terminal, mean to display, RMS to display. Now double click mean block, fundamental frequency 50, RMS block, double click, fundamental frequency 50, double click mean, fundamental frequency 50, apply OK, double click RMS, fundamental frequency 50, apply and OK. Now can we give the name of this one? Mean current, mean current, RMS current, mean voltage, RMS voltage. We can double click, right click on the three-phase source, go to format, show block name on, right click on this, go to format, show block name on, select, go to format, show block name on, select capacitor, format, show block name. Select scope, go to format, show block name on. Now your design as a three-phase RC circuit. Save your model by pressing save button. Now we are to change the simulation time as a 0.5 seconds. Now run the simulation by pressing run button. Now you got a mean current, RMS current, mean voltage, RMS voltage. Now we'll to see the input and output voltage and currents. Double click the scope. Now can change this term here. Configuration properties in the signal label as a input voltage. This one as a input current. This has a output voltage. Output current. Okay, now we are giving a three-phase input. So this has a input current. Now output voltages. So almost all straight line as a we are using as a capacitor. So we are getting as a almost DC output it is coming. Now you can to see some ripple also coming. Now you can see the zoom option. Some ripple is coming around. Now it is 84 and 2 volts are coming as a ripple voltage. Now this one also you have to reduce as a ripple voltage by increasing the capacitance value. Now this you will take as screenshot and save in the folder. Now this one is as a simulation on single phase and three phase RC circuit. Now hardware implementation on single phase diode rectifier with RC load. For this we required as a power module. Second one SCR diode power module. Third is capacitance, that C value is 5000 microfarad. Resistor load, the resistance value is 100 ohms. Now we want to see the output voltages. Digital storage oscilloscope. Hardware implementation on three-phase diode rectifier with RC load. So in the power module, three-phase supply is required. SCR diode power module. Third is capacitor. Between red and block, the capacitance value is 5000 microfarad. Between block and red terminal of resistor load, resistance is 100 ohm. Now we want to see the output voltages using digital storage oscilloscope. Here also you can see the diodes D1, D3, D5, D4, D6, D2. Here D1 cathode to D4 anode, D3 cathode to D6 anode, D5 cathode to D2 anode join. Where the anode and cathodes are joining of these, we are giving as a three-phase supply. All the anodes are joined to one of the capacitor terminal. All the cathodes are joined connected to capacitor positive terminal. Very important while making the hardware connection in the capacitor terminal, positive and negative is very important. In the single phase circuit, in three phase circuit also. If the polarities are reversed in the capacitor may be lost. We'll do the hardware on single phase diode rectifier with RC circuit. For this, hardware requirement is power module, SCR diode power module, capacitor and resistor load and digital storage oscilloscope. Now we'll do an hardware on single phase diode rectifier with RC circuit. For this equipment required power module. In that single phase AC voltage source, SCR diode power module. In that D1, D3, D4, D2, capacitor between black and red terminal. The capacitor value is 5000 and resistive load black and red terminal is 100 ohms. And to see the waveform in the output voltage with the help of digital storage oscilloscope. Now first we'll select as a AC voltage source from the power module, AC sub voltage to input of the SCR diode power module MCB, phase to phase and neutral to neutral. And diode D1 cathode to D4 anode, D3 cathode to D2 anode, and D1 D3 anode join, D4 cathode, D2 cathode join. And from the MCB output of phase terminal to where D1 cathode, D4 anode joining point to phase terminal, and from output of the MCB neutral terminal to D3 cathode and D4 anode joining point. From the D4 cathode and D2 cathode joining point to capacitor positive terminal, and D1 D3 anode joining point to capacitor negative terminal, and load positive terminal connect as a capacitor positive terminal, load other terminal connected to capacitor negative terminal. Now we'll make the connection of a single phase diode RC circuit. Now we'll make switch on the three-phase supply, switch on three-phase main supply, switch on meter switch, switch on power module MCB, switch on AC voltage source, switch on SCR diode power module MCB, and slowly increase the voltage to 35.3. Now we are applied as a 35.4 as a RMS voltage. Now we got an output. It is as a almost as a straight line. Why? Because we are connected in the circuit as a capacitor. So when we connected as a capacitor, we will get as a almost all as a pure DC voltage. From this you will measure the RMS and mean values are almost all equal. These waveform you have to capture in the PC. Open the open choice desktop, select instrument, select USB, OK, and get screen by pressing button. Now you can observe the as a straight line as a DC output voltage. Now these waveform you have to save in the folder. Now we are done as a single phase RC circuit. Now we will make it as a three-phase RC circuit. For this, make it of SCR diode power module MCB, and construct as a 3-phase circuit. Now first select as a 3-phase voltage source. Now this will get as a 3-phase supply to input of the 3-phase MCB, and D1 cathode to D4 anode, D3 cathode to D6 anode, D5 cathode to D2 anode. From the output of MCB OR phase, D1 cathode, D4 anode joining point as a OR phase. From Y phase to D3 cathode and D6 anode joining point. From B phase to D5 cathode, D2 anode joining point. Now we will make all the cathodes of D4, D6 cathode joining, D2 to cathode to D6 cathode, D1 anode, D3 anode, D5 anode to D3 anode. Now where all the anodes of D1, D3, D5 join in point to cathode, capacitor, negative terminal, and D4, D6, D2 cathode joining point to capacitor, positive terminal. Across the capacitor will connect as a resistive load. The resistance value is 100 ohms between black and red terminal, and capacitor value black and red is 5000 microfarad. Now connect the probe as a one of the resistive terminal as a probe positive terminal and other terminal to probe negative terminal. Now switch on 3-phase main supply, switch on meter switch, switch on power module MCB, switch on 3-phase AC voltage source, switch on SCR diode power module MCB, and slowly increase the voltage by pressing plus button. Voltage reaches to 61.2 volts as a RMS voltage. 61.2 as a RMS voltage of 3-phase voltage applied to your 3-phase circuit. Now you got an output voltage as a, we are using as a capacitor, you get an pure DC output voltage. Now you are measuring across the R load output. Now you got a straight line. Why? Because we are in the circuit, we are using as a RC circuit. That capacitor value is 5000, so you will get as a almost as a DC output. From this you will measure as a RMS voltage and mean voltage is all same. Why? Because there is no in the DC component there is no frequency value, so you will get as a mean and RMS are same. These waveform you have to capture in the PC. Open choice desktop and select instrument, select USB, OK. Get screen by pressing button. Now this output voltage as a 3-phase output voltage. These waveform are to save in the folder. Now we are done as a 3-phase RC circuit and single phase RC circuit, and you will bring back to your circuit to original position. Make it off your MCB of SCR diode power module. Make it off and reduce the 3-phase voltage to 0 and make it off your 3-phase AC voltage source. Make it off your power module MCB off and switch off your 3-phase main supply. Results of single phase and 3-phase diode rectified RC loads. Now we are done as a simulation part. Now we already captured the waveforms you saved in the some folder. So here you have to attach the saved screenshots. Attach the circuit diagram single phase diode rectifier with filter capacitor in MATLAB Simulink. Attach the waveform of output voltage, output current, input voltage, input current. Attach the waveform of output voltage experimentally from the DSO. This is regarding 1, 2, 3 as a single phase. Now fourth, attach the circuit diagram of a 3-phase diode rectifier with filter capacitor in MATLAB Simulink. Attach the waveform of output voltage, output current, input voltage. Attach the waveform of output voltage experimentally from DSO. This 4 and 5, 6 as a 3-phase circuit. Observations. Calculation performance parameter in Simulink. Single phase mean and RMS of voltage and currents. 3-phase values. Observation. Calculation performance from the experimentally single phase values and 3-phase values. Thank you.